Hello students, in today's class we are going to study about covalent bonding and covalent bonds. Most of these bonds are formed when the bonding is in organic compounds. For example, let us take example of carbon to carbon bond. In a carbon to carbon bond, this particular bond is known as a covalent bond and a bonding is known as covalent bonding. That means over here this particular carbon shares one electron. This particular carbon will also share one electron, and eventually this sharing of electrons form a bond which is known as a covalent bond. As you can see over here, covalent bonding is the sharing of electrons between atoms. This type of bonding occurs between two atoms of the same element or elements which are close to each other. So if you have H2, one H, one electron, another H, another electron, and both the electrons share. If you have Cl2, one Cl, one electron, another Cl, another electron, share. So either it is the same element or elements which are close to each other in terms of their electronegativities to make sure that these elements share a particular electron and the bond between them is formed properly. This bonding occurs primarily between two nonmetals. If you can see over here, I have given examples of nonmetals. Carbon is a nonmetal, hydrogen is a nonmetal, chlorine is a nonmetal. It can also be observed between nonmetal and metals as well. If atoms have similar electronegativities, that means the same affinity for electrons, covalent bonds are most likely to occur. Because both atoms have the same affinity for electrons and neither has a tendency to donate them, they share the electrons in order to achieve octet configuration and become more stable. Compounds generally have either a duplet configuration, that is two electrons in the outermost shell, or they have an octet configuration, that is 8 electrons in the outermost shell. 2 electrons is duplet, 8 electrons is octet. Now why are we trying to say this is because if I take hydrogen, hydrogen is 1 electron, that is it. So hydrogen needs to attain a duplet state to get stability. So what will hydrogen do? One hydrogen will share 1 electron. Another hydrogen will share 1 electron. And both these electrons will form a bond. So when I consider for this hydrogen, this particular hydrogen, I'll consider it to be like this. So this hydrogen has 2 electrons. That means this hydrogen has attained the duplet state. That means this hydrogen is stable. Similarly, when I consider for this hydrogen, I'll calculate it like that. So again, this hydrogen has 2 electrons, attained the duplet state. This hydrogen is also stable. In this way, we can actually do for another compound as well. Let's take chlorine. Chlorine is an important example. Why? Because chlorine is considered to be electronegative. And because it is considered to be electronegative, let us see how chlorine behaves. Chlorine has 17 electrons. So it becomes 2, 8, 7 as the electronic configuration. The outermost shell has 7 electrons, but chlorine needs 8 electrons in the outermost shell to have a complete octet. So what will chlorine do? Chlorine One chlorine, chlorine, another chlorine, and they will share. That means while counting the outermost shell for this particular chlorine, we will consider this electron as well, something like this. So for this chlorine, it becomes 2, 8, 8. And for this particular chlorine, we'll consider this one as well, this one. So this also becomes 2, 8, 8. 8 in the outermost shell states that it's a complete octet. That means chlorine is stable now. So because neither one of them want to donate, but both of them want to become an octet or a duplet, that is when they will share their electrons. And once they start sharing their electrons and they become stable, they attain good amount of stability, we say that that particular bond is covalent bond. In addition, the ionization energy of the atom is too large and electron affinity of the atom is too small for ionic bonding. For example, carbon does not form ionic bonding because it has 4 valence electrons. It's in half octet. To form ionic bond, carbon must either gain or lose 4 electrons. That is too much hard work for carbon to either give away 4 electrons or to gain back 4 electrons. And that is the reason why carbon always opts for covalent bonding. This is highly unfavorable. Therefore, carbon molecules share 4 electrons through single, double or triple bonds so that each atom can achieve a noble gas configuration. Let us first draw carbon. This is carbon. Number of electrons 6, electronic configuration 2, 4, valence electrons 4. This is total number of electrons. This is electronic configuration. This is valence electrons. That means it has 4 electrons in the outermost shell. Now for 4 electrons. Now carbon has many options. Either it gives away 4 electrons. If it gives away 4 electrons, what will carbon have? Only 2 electrons which were there in the previous shell and carbon becomes a duplet. Or take 4 electrons from someone else. Carbon already has 4 electrons in the outermost shell. Plus if it takes 4 electrons from someone else, total carbon will have is 8 electrons in the outermost shell forming a duplet. But either giving away 4 electrons or asking back for 4 electrons. 4 electrons is a lot. It is not 1 or 2 electrons, it is 4 electrons. And because 4 electrons is a lot, carbon neither gives nor takes but shares its electrons. For example, methane. Carbon has 4 electrons in the outermost shell, just drawing these 4 electrons. Let's take hydrogen. Hydrogen having 1 electron in the outermost shell. Hydrogen comes with 1 electron of its own. And hydrogen and carbon, they share electrons, and that is the reason why they form bonds. They are forming bonds. Carbon to hydrogen bond. Carbon to hydrogen bond. Over here also carbon to hydrogen bond. So if we can see, we realize that for this particular carbon, we have 1, 2, 3, 4, 5, 6, 7, 8. The carbon has 8 electrons. If we see for hydrogen, for this hydrogen we have 1, 2. For this hydrogen we have 1, 2. For this hydrogen again 2 electrons. For this hydrogen again 2 electrons. So we have hydrogen having 2 electrons. Carbon becomes an octet. Hydrogen becomes a duplet. Both of them are very happy. Both of them are stable. Both of them neither had to give electrons or take electrons because they are sharing the electrons and achieving a noble gas configuration. Covalent bonds include interaction of sigma and pi orbitals. Therefore, covalent bonds lead to formation of single, double, triple, also quadruple bonds. Over here we have example. This example we have phosphorus as the atom which is sharing its three unpaired electrons with chlorine. If we can see over here, we have phosphorus and this chlorine will make one bond. Phosphorus and chlorine will make another bond. Phosphorus and chlorine will make third bond, eventually forming a PCl3. In the end product, all four of these molecules have 8 valence electrons to satisfy the octet. So at the end, all the atoms, that means one phosphorus and all three chlorines are happy and stable because all of them have attained an octet just by sharing electrons. Bonding in organic chemistry, ionic and covalent bonds are the two extreme bonding. Polar covalent bond are immediate type of single bonding between two extremes. There are some ionic bonds which contain covalent nature, and that is the reason they are known as polar covalent bonds. Now, there are certain bonds which are covalent, but yet they are polar in nature. And these bonds show some kind of polarity. And because they show some kind of polarity, it is important for us to understand how they will work. Let me just give you an example of polar covalent bonds and also non-polar covalent bonds so that it gets a little more clear. If I have HCl sharing electron making a bond, H is 1 electron, Cl is 2, 8, 7. So H will share its 1 electron to form this duplet, and Cl will share its 7 electrons and take this one from here to form an octet. But what is happening? Sharing is happening. No one is taking anything from anyone. But yet H is weaker and Cl is stronger. So the bond is a little towards the side of Cl. If you can see that I've left some distance over here. So H gets a little bit of positive sign. Cl gets a little bit of negative sign. Delta positive, delta negative. Delta means very little. And this delta positive and delta negative acts like a pole. Correct? What is pole? Pole is nothing but two opposite kinds of energies which are separated by a little distance is known as pole. So over here I have positive on top of H plus and I have negative on top of Cl minus. So this delta positive and delta negative form a pole, and that is the reason why it is known as polar covalent bond. It's a covalent bond because sharing is still happening. Over here, if I have H and H, there is no delta positive, no delta negative. Both of them are having equal energies. If I have Cl and Cl, both of them are equally positive, both of them are equally negative. There is no transfer of energy, there is no delta positive, no delta negative. Over here, as another example, I can have water, H2O, oxygen in the middle, H over here, H over here. Since oxygen is a little more negative, it will have delta negative over here, delta negative over here, delta positive over here, delta positive over here. We can see two poles have been formed. One pole is over here and one pole is over here. So these bonds, such bonds are covalent bonds, but they are polar in nature, thus known as polar covalent bonds. Polar covalent is the intermediate type of bonding. It is between the ionic and the covalent. For example, most carbon-based compounds are covalently bonded, but can also be partially ionic in nature. Polarity is a measure of separation of charge in a compound. So you can see there is separation of charge, the negative charge and the positive charge. Over here also negative charge and the positive charge. A compound's polarity is dependent on the symmetry of the compound and on differences in electronegativity between atoms. Polarity occurs when the electron pushing element found on the left side of the periodic table exchanges electrons with the electron pulling element on the right side of the table. So now there are different kinds of elements, electron pushing and electron pulling. Basically, if I take sodium, it's an electron pushing element. If I take chlorine, it's an electron pulling element. Now, why do I say that sodium is electron pushing element? Now, when I talk about a number of electrons, when I know and how many number of electrons are going to be there. I understand that there is going to be only one electron for sodium in the outermost shell. If there's only one electron for sodium in the outermost shell, now how did I come up with one electron? Sodium is total of 11 electrons. Chlorine is total of 17 electrons. Okay. Now over here I'm talking about an ionic bond. But instead of ionic, if we want to talk about a covalent bond, let's talk about a covalent bond. So let's just take an easier example of hydrogen. Hydrogen, very easy example. We can actually use hydrogen for most of our examples because it will eventually have just one electron. So what will hydrogen do is hydrogen will try to push out this particular electron or take in one another electron. So since it just has one electron, so it can just push out and chlorine can take in, giving 18 over here. So that is how the polarity occurs, a positive and a negative. This creates a spectrum of polarity with ionic, which is polar on one extreme, covalent, which is non-polar on one extreme, and something in the middle, which is polar covalent bond. Both of these bonds are important in organic chemistry. Ionic bonds are important because they allow the synthesis of specific organic compounds. Scientists can manipulate ionic properties and these interactions in order to form desired products. Covalent bonds are especially important since most carbon molecules interact primarily through covalent bonding. Covalent bonding allows molecules to share electrons with other molecules, creating long chain of compounds and allowing more complexity in life. So thus in today's topic we understood what are covalent bonds. We also understood how covalent bonding is done, how covalent bonds are being formed, and the duplet and the octet state of a particular atom, of a particular element, can also be attained by simply sharing the electrons which they have in the outermost shell. There is no need to give away an electron or to take back an electron. There is always a third option, and that third option is sharing of electrons. Thank you so much for watching this video. Stay tuned. Thank you.